All right, today we're diving into something that is, frankly, pretty wild. It's a radical new idea for a language called I squared L. And get this, it's not for computers and it's not for speaking. It's a language designed to turn our shared imagination into something physically real, and it's a direct answer to a world that's getting saturated by AI. So let me start with a question that might bend your brain a little. What if you and a friend could both imagine, say, a pulsing sphere of light? And by doing it together at the same time, it actually appeared. I'm not talking about a hallucination. I mean a real detectable pattern of light that a machine could measure. This is the incredible, ambitious idea at the very heart of this imagination interference language. So, what exactly is I squared L? Well, the source paper describes it as a language that translates the synchronized imagination of two people into a physical event. Basically, it's a proposed bridge from our shared thoughts to measurable reality. And let's be super clear here. The authors really stress that this isn't magic. The goal isn't to invent some kind of new physics, but to use the physics we already have in a totally novel way. And this quote right here really gets to the core of why this was even conceived. The authors ask a question that's becoming more and more relevant every single day. When an AI can clone any style, any song, any image, how can we humans create something that's genuinely new and shared? I squared L is their proposed answer, a way to generate experiences that are, by their very design, completely and utterly unique. Okay, so how on earth does something like this work? Well, like any language, it's built on a foundation of words and rules. So let's break down the core components: the vocabulary, the grammar, and that critical moment where imagination becomes reality. First up, you've got what's called the lexicon. These are the basic words or morphotokens, and they're the fundamental building blocks. Each one represents a core concept you can hold in your mind, something like a mesh or a spiral. You can think of these as the nouns of this new language. But, of course, nouns alone don't really do much. You also need verbs, and that's where the grammar comes in. These are the operations that let you combine and manipulate those tokens. So you could attach a mesh to a hole, or you could twist a field. This is how you start to build really complex, shared mental images from just a few simple parts. Now, this table is basically the Rosetta Stone for I squared L. This is the key. It shows how a word like mesh isn't just some abstract idea. It maps directly to a physical field recipe, like a specific audio frequency or an optical pattern. And it also maps to a felt experience, the specific imagery the person is guided to hold in their mind. This is the crucial link that connects the word, the machine, and our imagination. So how does this whole system defend itself against that copy-paste world of AI? Well, originality is baked right into its code. I squared L isn't just designed to create things, it's designed to create things that have never existed before. It does this using two really important metrics. The first is the replication index, or RI. This basically measures how similar a new creation is to everything that's already been made. A high RI is a bad thing, it's a penalty. On the other hand, you've got branching gain, or BG. This measures the potential for a creation to spark even more new ideas. A high BG is a reward. The whole system is hardwired to hunt for novelty. And this all comes together at a critical checkpoint that the authors call the Benjamin Gate. So when two people try to create an event, the system checks its novelty score. And only if that creation is truly original, meaning it has a low replication index and a high branching gain, only then does the gate swing open and commit the event into existence. Let's walk through a quick example to make this concrete. Okay, user A chooses the token mesh, while user B chooses hole. They synchronize their timing, they focus, and then they both commit at the exact same moment. If the Benjamin Gate decides their combined idea is novel enough, the system renders it, creating a real, measurable, pulsing sphere of light. Your imagination literally becomes a physical event. Now that we've got the basics down, let's explore where this could actually lead. The paper outlines some incredible, almost science fiction level applications that involve expanding this language into some highly specialized fields. For instance, take the biolexicon. The idea here is to use shared thought to guide the self-assembly of actual biological components. So imagine two scientists focusing their shared intent to coax a simple pollen capsule into forming a living, breathing microreactor. They wouldn't just be imagining it. They would be co-creating a functional biological system. Then you've got the aerolexicon. This proposes using our shared intent to sculpt invisible fields right in the air. using safe bioaerosols and maybe even scents like pine. You could literally shape the atmosphere in a room through coordinated imagination, creating patterns that you could only perceive through smell or a feeling on your skin. And on a just profoundly human level, there's the neurolexicon. This explores I2L as a potential new communication channel for people with severe motor or speech limitations. A shared yes or no, imagined in perfect sync with a caregiver, could become a clear, measurable signal. It could truly become a new kind of voice for the voiceless. And the vision for this extends way beyond just sight and sound. The framework could be adapted to create interactions based on all kinds of other senses we see in nature, using principles of echolocation, sensing electrical fields, interacting with magnetism, or even creating localized hot and cold spots in the air. The potential to expand our sensory world is just vast. So what's the big takeaway here? Why does a language like this really matter for our future? Well, it's all about redefining what it even means to create something original. Here is the fundamental shift. We move away from creating objects, like a song or a painting that an AI can endlessly replicate, and we move toward creating timed events. An event created by the synchronized interference of two minds at one specific moment is, by its very definition, a unique and completely unrepeatable occurrence. The source paper wraps up with this incredibly powerful idea. The philosopher Walter Benjamin worried that mechanical reproduction destroyed the aura, the specialness of a work of art. Well, I2L suggests a new home for that aura. It's no longer found in the scarce physical object, but in the unique, fleeting moment of timed, shared creation. And that leaves us with one final thought. If this technology was real, right here and now, and you could link your imagination with someone else to create a single, unique, measurable event in the world, what would you make first?